All right, and we're here with problem number 10 from your chapter 9 and 10 practice test, where we're going to state the value of the discriminant and then determine the number of real roots to the equation. So we have an equation here, and we'll notice that it's not equal to 0, and if we're going to find the number of roots of the equation, we are going to set the equation equal to 0. That is what a root is. It's when a quadratic equation is equal to 0, and the value of x will be the root of that equation. So that's where the 0 comes from, because we're asked to find the roots of the equation, and just like with any general quadratic equation, we have to set it equal to 0 to solve the quadratic equation. So that's where we have 0 equals and then our quadratic on the right hand side. Now we're asked to state the value of the discriminant. Notice we are not asked to solve for the value of x. We are asked essentially to find how many answers are there for x to make this equation true. And the discriminant determines that, or tells us that. And in order to find the discriminant, we have to know what the discriminant is, and the discriminant is b squared minus 4ac. This again is the part of the quadratic formula that is underneath the square root in that formula. So whatever this is the discriminant, and depending upon what kind of number that is, tells us how many answers there are to the quadratic equation we are trying to solve. In this case, this one here, or this one here once we plug in 0. So we still need to know a, b, and c, and by having our quadratic equation in standard form, set equal to 0, we can clearly see what a, b, and c are. A is 6, b is 9, and c is 19. So we're going to take these values and plug them in. b squared minus 4 times a times c. And then we're just going to evaluate. 9 squared is 81. 4 times 6 times 9 is 456. 81 minus 456 is negative 375. And since the discriminant is negative, we can't take the square root of a negative number. So therefore, if the value of the discriminant is negative, then there's no solution to the quadratic equation, and therefore there are no real roots, because we cannot take the square root of a negative number.
Thank you.
No problem.